In this video, we're going to talk about graphing more functions in parametric and radian mode. So here we have a few examples. We have x equals secant theta, y equals tan theta. So let's go and punch this in. We'll switch our mode to polar mode, and radian's already selected. Then we're going to, oh, sorry, I meant to say parametric mode. There we go. All right, so we have x equals secant theta, so we're going to do 1 over cosine theta. Don't worry that there's a t there. And then tangent theta. And then we're going to hit graph. Before we hit graph, actually, let's make sure we adjust the window. So it's from negative pi to pi. So you have negative pi, a pi. And the step could be really whatever you want. Let's say 0.1 for a little more accuracy. Hit graph. So we see that we actually wind up getting a hyperbola in this case. And it looks like the vertex is sitting at 1. If you hit trace, yeah, negative 1 comma 0. Don't worry about the scientific notation. That basically just means 0. If you try to move to the other side, actually, we need to move to the right. So we want the t values to become positive. Yep. And we pretty much get something close to 1 comma 0. So that's how our graph will look. Now, what if I make a slight adjustment and put 2 in front of secant, 3 in front of tan? So you have to insert a 2 here. Actually, put a 2 up top, my bad. And we'll insert a 3 down here. And graph. So now we see that it actually is going to be at 2 and negative 2 for the vertices on the x-axis. So these are at 1. And these will be at 2 and negative 2. Now C is interesting because we're reversing trig functions. So let's see what happens when we do a little reverse. So I'm going to clear that, make that 4 tan x. I suspect that we're going to see this on the y-axis. So I do 2 over cosine t. Yep, and we definitely have it. Now, interestingly, it's at 2 and negative 2 for y. So it seems that secant theta is going to determine which way we open, whether secant is y or x. And the number in front of it is going to give us the vertex. I'm guessing the number next to tan is going to probably be the other dimension of the central rectangle. So we might be getting this. And in D and E, most likely will change the center. So let's actually make a little adjustment there. Let me clear the screen. And let's do negative 2, negative 3 in front of those. So insert negative 2 plus, and insert negative 3 plus. Oh, we'll just type it over again. Negative 3 plus 2 over cos t. So it seems as if it moved to negative 2 comma negative 3. Again, you hit the trace button. And that makes sense because you have negative 2, negative 5. And it looks like we'll have negative 2, negative 1. So it's opening up and down because that's because secant's next to the y. And the center is definitely at negative 2, comma negative 3. So the equation for this would be x plus 2, actually start with y, y plus 3 squared over 4 minus x plus 2 squared over 16 equals 1. So the central rectangle, again, our center is at -2, -3. And we're going up 2 and down 2. And then we're going left 4, right 4. And it looks like that. And we go back to the graph just to verify that. That makes a lot of sense. Okay. So now what we can do is we can predict the center and the orientation of the hyperbola and this measure the dimension of the central rectangle. And then we can do some conversions for part F and then work on example 6 after that. So here we go. So if I go to this here, so secant next to x, so it's going to be opening horizontally. That's a conjecture we made. And it's going to be x plus 1 squared over something minus y minus 1 squared over something equals 1. And your a value is going to be 1, and your b value is going to be 6. So we have 1 and 36. So the graph should look something kind of like this. The center's right here. We go 1 left, 1 here, and then we go 1, 2, 3, 4, 5, 6, way up here. 1, 2, 2, 3, 4, 5, 6, way down here. And again, it's opening sideways like that. Let's type it in just to make sure we got it. We got -1 plus 1 over cos t. Clear. 1 plus 6 tan t. Graph it. And there we go. There's a graph. So using Pythagorean trig identity to express each of the other parametric equations in rectangular form. So again, now we know what's up here. So this is x squared over 1 minus y squared over 1 equals 1. Very simple, right? This one was x squared over 4 minus y squared over 9 equals 1. Now this is reversed. Y squared over 4 minus x squared over 16 equals 1. Here the center is at -2, -3, so we're going to say, and secants with y, so we're going to do y plus 3 squared over 4 minus x plus 2 squared over 16 equals 1. Now, in the last page here are these notes before you guys do the problem sets. We're asked to change each conic from rectangular form to parametric form. We'll come back to the parabola. That's part A, because we haven't really talked about that. But for the circle, we already seen that we could just do x equals y equals, and that would be that'd be 1 plus sine theta. And again, we can go back to our notes here. And that's what we noticed for all that. And the radius actually, I need to get the radius too. Forgot to take care of that. Radius is 1, so yeah, I don't need coefficient from cosine sine. So your center was -5,1. Again, your radius is 1. Okay, let's move on to ellipse. So for ellipse, the center is at 0, 0. Sorry, 0, 1. So you're going to say x equals, and now in this case, you're going to say, well, you don't have to put anything next to plus, but you could say and that's root 8. So it'd be 2 root 2 cosine theta, and y will equal 1 plus 3 sine theta. And then finally, we have a hyperbola here. We'll say x, so y equals 6 plus secant theta. This is over 1. This will be negative 4 plus 2 root 3 times tan theta. So that's what we have going on for that one. Hopefully those make sense working backwards. And then lastly, for number 6, part A, for parametric, we're going to let t or theta, whatever you want to use. We'll use t, I suppose, equal whatever the squared expression is, y plus 7. So you have negative 8 x minus 5 equals t squared. So x minus 5 equals negative 1/8 t squared. X will be 5 minus 1/8 t squared. So it's kind of it's kind of open-ended, but usually a quick way is just let t equal the squared expression or whatever binomials being squared or terms being squared, variable expression being squared. Let t equal that, and then get x in terms of the other. And of course, y here technically would be t minus 7. So those are actually your parametric equations. Okay, that concludes the video.